Welcome, everyone. Today is April 27th, and this is another installment of SIG Apps community meeting. My name is Maciej, and I'll be your host today. I don't have any particular announcements. We only a couple days ago released Kubernetes 136, so congratulations to everyone. We're currently thinking through 137 items, and actually Nathaniel is here with us to talk about one of the potential elements we're gonna be considering for 137. So Nathaniel, take it away. I'm gonna stop sharing my screen because I'm guessing you
Okay.
gotta just follow through with your document. So you should be
All
able to
right.
share your screen.
Let's see if I get it up. Can everybody see my screen okay? Okay.
Yes, now we
Okay,
can.
good. Awesome. All right. So I think the main action item, I came to the meeting, a previous meeting to talk about this, and I think one action item was to put together a doc. So this is that document to talk through and try to get input from the community on what we can do here. So just to refresh, there's some interesting coordination problems between sort of the replica set controller and all the other controllers that do things like the scheduler or Carpenter or Kubernetes autoscaler, various things in terms of picking which replicas get scaled in when you have a replica set count drop. Um, and currently, just as a reminder, it's the current heuristic is, pod status, which I totally agree with. I think we should continue with that. Then we have a sort of beta feature with pod deletion cost annotation. And then the next stage is kind of a pod spreading heuristic where it chooses, the node with the most co-located replicas and picks those first when it chooses a pod to scale in. Um, and then it kind of goes through some other stuff like whichever pods were newest get picks first and stuff like that to kind of tie break all the way down to random. Um, and so when you have a spreading heuristic, that's really good for availability, but it can kind of fight with auto scaling goals like maintenance windows or consolidating to save costs on compute, things like that. It's particularly rough when you need to empty out nodes completely in order to reclaim them. That can be the case sometimes with Kubernetes autoscaler, and also you can configure Carpenter to only scale in nodes that are empty as well. Um, and then I've also talked with a few people now that have mentioned that they have sometimes trouble supporting their scheduling goals with the replica set controller right now, just because it doesn't care about scheduling or anything like that. It just kind of does its simple heuristic and goes from there. And if it helps the scheduler, it's kind of just inadvertent in a lot of ways that it helps it because it's not trying to. Um, so anyway, that's kind of the background. I've prepared this doc. It kind of has one example of how it doesn't support like capacity compaction or trying to consolidate the cluster for efficiency. I've tried to gather some other use cases that we know about. So I know working group serving had one about load, being aware of load. I haven't put it in here, but I've heard somebody talk about being aware of leaders versus followers within an application. And there's also like node maintenance windows. We call it drift in Carpenter, but just being aware of that. And even just node conditions in general, it's not really aware of those when it makes its choices. And then I mentioned the scheduling constraint ones. And then there's also this interesting case of when you have co-located workloads with different tolerances for disruptions, like think stateful sets, think batch jobs, which you don't really disrupt on purpose if you can help it most of the time. And then you could also label things in Carpenter do not disrupt with an annotation. So that's kind of another example. And then like this last one is just this handling competing concerns. So you have a lot of potential actors that might want to have a say in which pod gets chosen to scale in, and how do you reconcile that is kind of another problem. Um, so if you have any other use cases, I've put in a call here for more of those to collect those. I just talked with Ryan in SigNode earlier this morning, who's also collecting sort of adjacent use cases for this um, node transitions kept that he's working through. Um, and so the last thing I'll say is from for this crowd, probably the easiest thing we could do is just create another heuristic and make it feature gated for people to have. It would kind of be a one-to-one swap for the current heuristic. That's kind of the simplest thing you could do. It doesn't do any solve most of the problems above, but it does give people more options as to how the behavior goes through when it's picking the pods. So like you could have a heuristic that cares about load, or you could have a heuristic that cares about emptying out nodes. And that would be like the simplest thing you could do. And it doesn't really change much, and it still wouldn't support scheduling goals or a lot of things, but it's something you could do. There's an option B, which I'm actively pursuing with the Carpenter and SIG auto scaling, which is just to make use of the deletion cost beta to allow Carpenter kind of talk with the replica set controller. And then kind of the long-term option that I'm kind of envisioning right now is to kind of integrate with this workload aware scheduling work and try to make some part of the scheduler the brain that sort of smashes all these different concerns together and then tells the replica set controller, hey, this is what you should do via some mechanism, whether it's the annotations or some sort of API or something like that. So anyway, that's the whole doc. Feel free to comment, add use cases. I'll be here for questions now or comments.
Um, I was looking and I've noticed that someone was also commenting somewhere in the document around the gated approach and the replication controller, where we would basically um I guess expand the current spec with the ability for you to say, oh, this is the way that I want you to handle the deletion. The only downside of that kind of an approach is that you're basically encoding a value that still would have to be updated on a maintenance based window. You basically have to go figure out which pods are affected through that, figure out which replica sets are, and then modify those values. I wonder still about the approach, and I haven't seen any discussions around it. And you feel free to prove me wrong, because as you mentioned, you've been talking with various folks on various venues. I remember last time when we talked, I was one of the ideas that I had in my head that I was considering, and I wasn't sure what would be the long-term path, was decoding the already available scheduling information that we have on the pod. And that way you wouldn't have to modify because the information about where your pods are landing is already encoded. And you could look at that and based on that, make the decision for deletions.
Yeah.
Have you discussed that as an option for potential, I don't know, figuring out who could be a potential candidate for removal? Because that would basically adapt towards whether you have spreading or consolidating, because that would already be expressed through the scheduling information, basically.
Yeah. It's interesting. I don't know. I'm trying to think if I've talked with any of the SIGs about it, but I have talked with some of the principal engineers around here. They're So the downside of ingesting the scheduler directly is that it doesn't really. I'm going to talk from the autoscaler perspective for a second. So from the autoscaler perspective, it's kind of all or nothing whether a node goes away or not. For example, like if you're using consolidate when empty or underutilized setting on Carpenter, for example, if you spread out your deletions at all, you're just kind of signing up for more disruption later when it picks a node because So kind of what you want to have happen is you want it to focus as much as possible on a single node from the autoscaler perspective, or a small set of nodes, depending on how much of a scale-in it is. Um, and so you kind of weigh that against what the scheduler wants to have happen, which is whatever the pod is encoded. And it says, well, I want to spread out, or I want to do this, or I want to have affinity to this, and and so you kind of have to have something that smushes those two signals together, and then tries to decide, okay, these are my priorities as far as nodes, and these are the ones that I should go for first. And so then it becomes, well, where does that brain live? And then what's the structure of it? And the principal engineer actually really liked the one aspect of the annotation beta thing, in that it smushes the signal down to one number and then just communicates that number to the replica set controller. And so you kind of have this like, so the brain is elsewhere. Like all replica set controller has to do is take this one integer, and then that's all it has to care about. And ideally, from the autoscaler perspective, that integer should be the same for every pod on a given node. Um, because then that sort of unifies that node's priority in the pods on that node. So you're more likely to empty stuff out. And so then it becomes, so once you have what, if you accept that architecture of the problem, then like where does the scheduling concerns live? Well, it would live in like the workload aware scheduler, it would live in Carpenter, it's whatever is doing the smushing down to the one number, so to speak, that you're trying to get out of it. Um, and and then at that point, there's some place in the system where you need to be like, okay, here's what I care about in terms of availability and resiliency and cost, and it's some sort of high level objective that you set. And then the thing that's smushing the signal should have some way of kind of balancing those concerns, into an integer essentially for the replica set controller. Does that make sense? So yeah, go ahead, Philip. Yeah.
Matthew, do you want to add to this
No, no,
second
no, go
question?
ahead.
Yeah, I would like just to say like what I have observed. Like there is like this new auto-scaling workload error scheduling effort, and they are basically looking at this kind of similar issue, that they want to move like the scheduling decisions from the autoscaler to the scheduler. And the main reasons are that basically the scheduling is getting more complicated, complex. And you also like need to solve like the issues of like multiple schedulers or plugins, and like see where basically simulate where the pods will end up, and like which kind of constraints you want to promote. And so would utilizing like the new workload APIs or like podgroup APIs help here? Like if we could have, because this is basically like a scheduling API. So like I know like it would not solve this like for all your workloads, but for the most painful cases, like the user could maybe set a field to the pod group and say like this is the kind of disruptions I would like to prefer.
Yeah. Like, I mean, you're exactly right. Like, right now, the biggest weakness of the annotation beta is the fact that there's no clear owner of the annotation. So, like, if you go look at my Carpenter RFC that proposes, Carpenter trying to use this to help the replica set controller pick the right, pods. One of the biggest defensive things that you have to do is check if something else is setting it. Like, did somebody manually set the deletion cost, or is there another controller fighting for the control of the deletion cost? And so from that perspective, like when you go to this workload aware scheduling APIs, scheduler aware APIs that are sort of smashing together the scheduler and the auto scaling provisioning side of things. One of the big wins that you could get out of that is clear ownership of like who's communicating this to the replica set controller, and how is that signal being generated? Like, is there an API, or is there, whatever communication channel we choose? Um, but like having like the brain be kind of have like a central brain, like this is where the brain is, here's how you pass your concerns and what you want to have happen to it, and then it kind of smushes it all together, and then it tells the replica set controller what to do essentially. Is kind of how I would envision maybe one way this works out. I mean, there's probably other ways of doing it, but
I guess one question I have is that if the long-term thing you want to do is eventually get the cluster autoscaler to work with the default and potentially other schedulers in order to have a less disruptive way to scale in and out that's aware of workload placement and like declared intent in terms of topology spreads, along with like, you know, various constraints around the workload. And you want to add annotations that are going to be consumed by built-in controllers, right? Like it's not just the built-in controllers that would have to consume them to be useful. You're going to have third-party controllers. Anyone who wants to be part of the ecosystem has to adopt in. If you're going
Yeah.
to do that and then evolve away from it, does not create a significant amount of technical debt across the ecosystem. Like
Oh yeah.
that's kind of the scary part for me. It's like if you want to do B, I can see like a motivation. But if the goal is really C and it's like let's do B first and then pivot to C later, that becomes kind of scary to me.
So, I mean, the nice thing about doing the so like if you take let's break apart the thing. So like doing an alternative heuristic for the replica set controller, I don't feel like that locks you into much long-term technical debt wise, because you're just taking you basically haven't changed the overall ecosystem. You've just added an option that people can opt into or not. When you go to the Carpenter deletion cost thing, that one is super easy to back out of because I mean, literally, you can just stop. Like right now, the way it's set up, you could just turn off the feature flag and it stops sending the annotation, and then it just kind of drains out of the system naturally, and you don't have to worry about it. When you get to C, when you start having the brain, you start defining APIs and things. Like you're right, like you're locking yourself into a lot of decisions that you're gonna have to deal with longer term, technical debt, things like that.
Well, that's
Yeah. Yeah.
I would push back on that a little bit because the reality for most of our customers today is that so there are some people who are controlling their own feature flags and they are deploying their own control planes. But by far, consumption seems to be driven by CSP delivered control planes that are managed externally. And those customers, and except for various offerings for people to test things out, they're not really in control of their feature flags, right? Not entirely. So if you put it in alpha, they're not going to get to see it till it gets to beta sometimes. And nowadays, it's actually getting more towards like the major CSPs aren't opening the feature gate until it gets to GA. So now you release it to GA to actually add value. So, okay, we're at GA. There's no way to remove that or back that out ever until you release V2 of replica set. So like it's a long-term thing. Like once you say that's a semantic we're going for, it's never going away. And like if
I,
we do that and then we say yes, and we're going to do this other thing as well, now we've got both. So if we're going to do both, I'm not saying like that's a priori the wrong answer, but I think we should strongly motivate why we should have both of those things in the ecosystem in the long term. And remember, once you release it and the annotation is out there, it's not just the built-in controllers that might want to consume it, but there are a relatively large number of third-party and add-on workload schedulers that may consume it, right? So and we have to be sensitive to them too. Once it becomes part of the V1 surface, it's there for them too, right? So it's not like we
yeah.
can just do A and B and then back them out later and replace them with C. There's no mechanism to do that really. Like it's like
Yeah.
if we do B, we're going to do B, and if what we really want is C, then we're going to do B and we're going to do C.
Yeah. So for like the replica set controller one, I'll address that one first. It's probably going to end up being more like the scheduler plugins because it doesn't really make sense to make like there's no way in advance to know whether you want one heuristic over the other without somebody configuring it. So like for example, like right now for EKS, for example, the scheduler comes in default with least allocated scheduling. And you kind of have to do some work to override that if you want to use most allocated. It would be something similar for replica set controller because the reality is like the right heuristic is going to vary from workload to workload. And so I would never envision like making it the default, let's say. You would have to pick one or the other, and it would be similar to what the scheduler does today. For the other stuff, you know, I think we need the ability to communicate priority and align the stack. And there's probably like right now, it seems like the when I attend the other meetings on the schedule, you know, the workload aware scheduling, it seems like they're kind of going with like a scheduler library API sort of approach. And so like all these third party kind of controllers and things like that would have an API that they could optionally implement is kind of seems like where they're going. But I mean, it's still so early. It's like hard to say like what that's going to look like at this stage. Um, I think we should be aware of this, and we should be aware that the replica set controller needs to be told what to do or have some way of kind of communicating the priorities that it has to the system. I honestly I like the hub and spoke kind of architecture where there's like a brain and then it communicates the preferences out so that you avoid more of the split brain problems that Kubernetes has so much of. The alternative architecture to that is just having heuristics that don't care about each other, but they generally align in goals, which is kind of sort of what the replica set controller heuristic would be.
I mean,
Uh,
that was the original design constraint for Kubernetes itself, right? Like if you go back,
yeah,
Borg is a monolithic scheduler. So, and there
yeah,
are challenges with having a monolithic scheduler as well for scaling and so forth. So a lot of the original, like the idea that we would have plugin schedulers and that we would have workload controllers that specify for like that was a design goal. And there are trade-offs there, like you're saying, for sure. But to say like I don't think we can step back and say, well, monolithic's a good idea now.
yeah. It's it's a big goal. I mean, like Carpenter has become relatively popular, and so I think the idea a lot behind it is to try to get some of that smarts, into the scheduler itself, so that the auto scaling and scheduling are coordinating more closely. And if they do the scheduling library right, third-party schedulers like Volcano and all these other ones like should be able to integrate pretty nicely with it just by implementing the API. Um, so I don't know. We'll see. I mean, this is a bigger discussion than just this one doc, and there's a lot of like ecosystem-wide things that are getting kicked around. But I mean, you raise good points. I just don't know that I can answer them from just this one problem by itself. We can get it. We can kind of get into it, but from this perspective, but we can't answer everything. I'll be there on Tuesday on the next tomorrow morning when they continue the discussion on the workload aware stuff. But
I think that there are a lot of challenging concerns because if you do look at a lot of the things that have arisen that are not default schedulers, they also tend to come with their own sets of workloads. So it's like I'm not just going to re-implement the scheduler, but I'm also going to re-implement the workload controllers that leverage that scheduler in order to achieve specific results, right? So
yeah,
the question is, do we build the puzzle pieces the right way such that I can bring my own scheduler and other workloads can benefit? And do we have the right signals for sharing that information across both infrastructure schedulers like cluster autoscalers as well as workload schedulers, right? Like we have pain points.
yeah, and whenever you have components that are just kind of independent of each other, it seems like the magic is always getting the API right. Because so I think that's where I think if we can get that right, then all these other schedulers can have a clear way to interact with the system and plug in without breaking stuff that they don't even know about. You know. So it's like they were supposed to be sending this signal and they didn't, and then stuff broke, So if you can kind of avoid that if we get that API right. So other comments, questions? I tried to add the working group to the doc with review permission, so anybody can go in and edit or add things if they want, comments, things like that.
Given where we're at with both the B option, because that's already there, although it's beta, so we still have the ability to either decide to move it to full EGA or eventually if the C will be the most viable option and everyone will be uh, slowly building towards that direction, we can always say, well, we decided to drop the pod deletion cost. My suggestion is to not rush on anything for this one. And
Okay.
let's see how the situation plays out because I know that a lot of the work around the workloads or scheduling specifically, it has a very high priority in multiple places. So there's a lot of work going on to push this through as hard as possible. Over the past release, I'm pretty sure that the same will happen this release. So if that would be okay with you, I think that would be the best option. In parallel, we can also continue gathering some feedback from other people.
Okay.
Um, there's still the work coming from the SIG node around the eviction API, as you pointed out in the doc, which Philip is partially also involved in with regards to the eviction and the node statuses and exposing those in general node lifecycle, which could potentially also be a good input for those kinds of decisions, especially that um, the pod deletion cost, a significant downside is that it only applies to a single controller.
Yep.
I mean, I've been thinking a little bit but I cannot figure out how we could apply something like that for other controllers.
I
So it makes sense for the built-ins a lot, right? Like, I mean, for stateful set, you already kind of have the orderings for deletion based on the
Yeah.
orders, right? And then daemon set, you're applying
Well,
on a per node basis, right? So like
yeah.
priority bands are probably more applicable for daemon set, right? But then that's the other thing I think about. Like we already have priority bands as a pressure. We have we're getting a lot of different signals. So,
I mean, partially because the stateful set has currently the parallel pod strategy, which theoretically does allow you to scrape the entire thing, at which point in time you don't care about the ordering because you drop
right.
the entire thing, unless the deletion of your particular application takes a little bit longer. But I'm guessing at that point in time, it's still a matter of, I don't know, minutes, maybe even if an hour. Building entire mechanisms around it seems somewhat unnecessary, rather than just waiting this that whatever the time is. So yeah, I think it's better to have a little bit more holistic approach rather than just one-offs here and there. And for now, at least, live with the fact that we have the pod deletion cost being beta. Um, let's see what the people I will definitely sign up for the Carpenter issue, and we'll see how and where that thing is moving, in what direction. Um, and we can always make appropriate decision.
Okay. So the idea is kind of gather some data using Carpenter as kind of the guinea pig with the pod deletion cost, and then kind of upstream what works and avoid
Yeah.
whatever doesn't.
Yeah,
Yeah.
I guess that's a reasonable follow-up steps. Um, yeah,
Okay.
go ahead, Philip.
Yeah, I have not seen it in your cap, but I guess like from what I've gathered from this discussion, like we would probably need like a new field for the replica set for the option A. So that's, as Matthew was mentioning, like that's very problematic to not know like what where we will be heading from now on.
Yeah, we could still do it. I mean, I'd be happy to push it through, to work through it if we wanted to experiment there. But it, there's nothing stopping you from having this other like even right now, like if I push the heuristic right now, like the selectable heuristic, the pod deletion cost would still exist and be able to override and so whatever mechanism we end up going with, like if we get to option C, presumably you could do the same thing. I don't know. I'm
Honestly,
not wedded to the idea, but go ahead. Yeah,
honestly, between option A and B, I would prefer B because you have a direct information and you're modifying
fair
the
enough.
affected pods only rather than, oh, I need to figure out which are the pods. Do another step. Oh, I need to get to that replica set. Modify that. Then the replica set will have to react rather than, oh, I'm just modifying the affected pods. You're done.
Yeah,
Which oftentimes will be basically, oh, it's a no op. because we don't have any pods affected. And so we're basically ignoring that. So yeah, between A and B, and I believe that what you also, Nathaniel, you are leaning towards as well. It's probably just A is there just as, oh, we started a discussion, but from what you were saying, you were basically leaning towards B and ideally C.
Yeah. I mean, that's kind of how it went in, like with the engineers here locally, like at AWS. Like everybody started out, well, why don't we do it on the replica set controller? And then as we started thinking it through more, like we all kind of ended up, oh, it needs to be somewhere else. Carpenter or the scheduler or something that has more information about what the system's doing and why and that kind of stuff. So I mean, it's not a surprise to me this is where we're ending up because of that, but I wanted to.
Wondering for other sample groups, right? So like Azure's built-in capability for right sizing is primarily based on open source Carpenter. At least it's what they say in their documentation. And then Carpenter, provider, or Azure is a thing. EKS, like the industry trend is toward basically the CSP is going to manage all the things for you. So EKS auto clusters is a thing, and that works on top of Carpenter as well. OCI, I don't know if they even have a thing, but I know you can get Carpenter to run on top of it. So it seems like for the ecosystem, for most of the CSPs, Carpenter is becoming like the de facto standard, with GKE having auto mode as a slightly separate thing. So I would be also curious to hear from like the GKE folks about like their thoughts on it.
Okay. Sounds good.
Okie doke. I guess that was the only topic. And if there are no other questions, we can call it a day. Thank you very much, all, and
Thank you.
see you next time.
Yep. Thanks, everybody. Take care.
Bye.